start. We are on 3D stuff, right? 12.1. And we're going to look at some specific situations. We're going to look at surfaces, spheres, and cylinders, amongst others. The kind of surfaces that we're looking for are going to be planes. Oops. So let's look at plane. In the 3D world, a plane is the name you give to an infinite surface that's basically a flat piece of paper bent at an angle. So can you imagine all the points on this piece of paper I'm dangling in front of you? If I turn it on an angle, maybe you can see a little bit better, right? You can see it's in 3D, right? It's not just a flat, you know, it goes at an angle. Equations that look like that, they're called planes, right? So a plane would be like a flat piece of paper. So yeah, it's not bad, right? It kind of looks like it, right? They have an equation, the whole family of them, because there are lots of them, and they have an equation that looks basically like this. So an example would be that. That would be a plane in 3D. It's a linear combination of X, Y, and Z. It's the closest you're going to get to, you know, a straight line in 2D. Wouldn't a straight line in 2D have an equation that looks like that? 3x plus 2y equals a number. Wouldn't that be, if you rearranged it, wouldn't that be the equation of a line in 2D, right? So can you see that when you move into 3D, a 3D version of an equation that looks like a line ends up giving you an infinite number of points, right? It gives you all the points on that piece of paper called a plane. And we have some software, which is called GeoBra, that allows us, thank goodness, because that means I don't need to draw it anymore, allows us to draw them. So hopefully you are looking right now at, let me cross it off. Are you looking at GeoBra, guys? Right. So up here in input, I don't know if it takes it this way, and if it doesn't, I've got another way of doing it. But here's 3x plus 2y plus 4z equals 12. Now, see that grey thing that you're looking at, this grey shape? That's really just the XY plane. It's put there as a good reference. I call it the floor, right? The XY plane, you see it. Now, this guy here, right? This fella here. Now, the cool thing is if you hold your mouse pointer, you see you can rotate it and get different views of it. There. Now, if you look at it really carefully side on, doesn't it look kind of like a straight line if you were approaching it from one particular direction? But isn't it really made up of an infinite number of points? Now, this plane continues in all directions, right? It's not a rectangle. It looks like it, but that's just the way GeoBra draws it, because it's kind of difficult to draw something that's infinite, right? So that's what you're looking at. And that is a plane. Now, I am going to put in the plane x equals 2. So make that guy go away. X equals 2. That is a plane, right? It's got 1x plus no y's plus no z's equals 2, right? So it figures that out. What would that look like? Try and describe it to me in English. What would x equals 2 look like in this picture? I'm going to orientate it a little bit. Yeah, that's me go to the orientation that you would use. So the green is x, I think the green is x anyway, and the red is y and the blue is z. X equals 2. What would it look like?
It's going to be a vertical plane on the YZ axis.
Well, parallel to the YZ axis.
Yeah.
And passing through X. There we go. So I better orientate it again. There we go. The red was actually the x-axis. It's hard to tell on the color scheme, right? Now, if you put in y equals 3, won't you get, oh, I don't like that color. Let's see if I can make that a different color. How do you change the color of these? Is it settings? Okay, there we go. There's so many things I keep forgetting about. Can you see that that guy, the pink one, is what y equals 3 is like? If you plotted all the points whose y coordinate is 3, wouldn't it be something 3 something, right? And the x and the z basically generate the infinity of it. And if I orientate it correctly, I probably should hide this one. If I orientate it correctly, can you see the 3 on the green? You see it there? So if you're only one number or one variable, x, y, or z, don't you get a vertical or a horizontal plane? And what would the horizontal plane be? Well, how about z equals 2? Can you see that's horizontal? If I orientate it a little bit better, can you see it floating above the floor at height of 2? So any equation in 3D, any surface written as so many x's plus or minus so many y's plus or minus so many z's equals a number, that will always get you a plane, right? A sloping, infinite flat piece of paper. And if you only have one variable like x, y, or z, don't you either get a horizontal or a vertical plane out of it? So you got a pretty good picture of what that would look like. Now, let me get rid of these 3 guys. How do you get rid of them? Oh, there we go. Delete that one, and delete that one. Now this one's this is going to test your 3D brain, because you don't use 3D brain much in math, right? We've always worked in the 2D world. Right? That's been your most common thing. I'm going to write the equation y equals 2x plus 1 down, but in 3D space. Y equals 2x plus 1 in 3D space. What the heck would that look like? It's a plane, by the way. You just rearrange the letters. It's still a plane. Any ideas?
Would it be a slanted plane?
Yeah. There it is there. Now, what is interesting about this plane is that if you orientate it correctly, isn't it basically, it cuts the floor with the equation y equals 2x plus 1. So you can imagine if you just did the plane and it hit the floor and you looked at the floor, you say, oh, there's a line there. And that line has the equation 2x plus 1, right? Y equals 2x plus 1. What would y equals x squared look like? Y equals x squared. Well, on the floor, wouldn't it look like y equals x squared? What's missing? Z. That means y equals x squared going vertically upwards. So shouldn't it look like a big curved piece of paper going vertically upwards? Let's see if I'm right. Y equals x squared. What happened to that? Go away. I may have put something else in here by mistake. There we go. Prove me right. Where is my curve? Okay. Okay, it's converted it to that, but that's not the correct shape. I'm doing it down here. Tell me why you're not going a curve. Oh, you are a curve, I guess. No, you're not. You're just a plane. You're going to have to trust me on that. I'm not sure what I'm screwing up on GeoBra, but it is, in fact, what I said it is. So I'm going to leave this guy for a second and try and show you what it would look like on 2D paper. Maybe I'll figure out later what it you know, what it would look like. So there's your x-axis, there's your y-axis. If you draw y equals x squared, because of the orientation, doesn't have to go that way. Right? Can you see it? Y equals x squared. Right. Now, whenever a variable is missing, the one that's missing, in this case, it's the z one, that tells you what this surface does. In other words, this surface would look like this. Yeah, that's why I'm not an artist. Can you see a curved piece of paper? That's what I should have seen in GeoBra, but evidently I can't type correctly. So let's look at some other guys. This is going to be, again, I'm going to try it on GeoBra. And if it doesn't, then I can do my backup. It may be because I have to rearrange the equation. I guess that could be the case. Right. If you want to do a sphere in 3D space, oh, now you do x squared. Okay, you're just playing with my brain here. There's plus y squared plus z squared equals 1. Ah, success. Do you see a sphere? Well, I mean, I know it looks like a circle, but if I can rotate it, there. Can you see a sphere? There. Cool. What do you think would happen? Well, what would you think would happen if I changed that 1 to 9?
Wouldn't it change the radius to 3?
Correct. And let's go over here and see if I can change the color to that one. Oh, isn't that pretty? Haven't I just modeled a very primitive Earth with our iron core and the rest of it going on? All right. That's kind of cool. What do you think would happen if I changed the x squared to a number, I don't know, like 2?
Would it turn into a cylinder?
No, but I can understand that as a possibility. Any other suggestions for what it might turn into?
Would it
just
turn
be
it
like
into
a
an
flat?
oval sphere?
Yes, it's basically the 3-dimensional version of a flat thing, yeah, an ellipse. Let's make it a little bit bigger. That way you could probably see it more. Right, and let's make this guy go away. Can you see an ellipse? And doesn't it look a little bit like one of those chocolate thingies, M&Ms, right? Do you see that you could model the shape of an M&M in 3D space relatively simply? It's not a really messy formula, right? It's just a matter of a multiple here or a multiple there. So that is them. Now, you mentioned a cylinder. This is what the equation of a cylinder looks like. X squared plus y squared equals, oh, I don't know, say 9. Now, let's take this guy. Looks a bit like a circle right now, agreed? That's because my orientation is on this. I'm up here looking right down on it, right? I'm in the aircraft looking down. Now, if we orientate, okay, there we go. Can you see a cylinder now? Now, do you notice that the direction of this cylinder is vertical? And I know that it's vertical because the equation is x squared plus y squared. If there's a variable missing, that's the direction of the shape, right? So in this case, it's Z. If I change this shape to x squared plus z squared equals 9, do you see that the orientation of that shape is now in the direction of the y-axis? Right, this here is the y-axis. So if I turn it a little bit, can you see it? The y-axis. So when you're trying to imagine what a solid looks like, the variable that's missing is the direction that the basic surface is going to be pointing in, right? And I'm going to try x squared again, because I feel brave. Darn it in space, it doesn't want to do x squared. I can do x squared. I can make you do x squared. You're going to be... Okay, you're just not going to cooperate. Okay, you have fun trying to do the y equals x squared. It's my only failure so far, right? All the others have worked pretty well. So, surfaces in 3D space. If it looks like this, it's a plane of some sort. If it looks like this, it's a sphere. Looks like this, it's a plane. A plane looks kind of like that, right? Sphere kind of looks like that. And if you only have two variables, like say this, then you're going to get a cylinder. And the cylinder is going to be in the z direction, right? But if you get x squared plus z squared equals 9, you're still going to get a cylinder, but isn't the cylinder going to be in the y-axis direction? Does that make sense? So you can tell orientation. That's just a fancy name for which way something's pointing. And if you do y equals x squared, you're a better man than I am, because I can't make it do it. But y equals x squared will look like y equals x squared. The variable that's missing here is z, so you know it's going in the orientation of the z-axis. Any questions about that? This isn't really so much questions. This is us just trying to get your brain to think in 3D, right? What the equations and what do things look like when you do them in 3D, right? They're surfaces for the most part. So let's see if I can find some questions to do with spheres, because there's a lot of them in spheres. Now, I'll start off with the basic one. This is a sphere. Radius of 3 and center the origin. Great. What would this one be? Well, it would still be a sphere. It would still have a radius of 3. So far, so good. But what would be the coordinates of the center of this sphere? Because it won't be the origin anymore.
One comma -2 comma 0.
Correct. I'm assuming that you're using a kind of an understanding from the 2D world. If I make this Z go away, isn't that the equation of a circle in 2D space? And doesn't that circle have a radius or a center of 1 comma -2? Is that essentially what you were doing, Cal?
Yep.
Yep, that's how you do these things. I'm putting this in because I just want to. You're not going to be asked anything. Haven't I just written down the equation for the surface of a fourth dimensional surface? And this would be called a hypersphere. You stick the word hyper in front of everything when you go beyond 3 dimensions. There's a really cool animation of a hypercube. It's a fourth dimensional cube. And they do an animation to try and make you think or to visualize. And since my brain is on this, let me just take this moment to show you what's going on. This is the closest I've ever got to understanding fourth dimensional surfaces. Right, here is a cube, right? 3D. If you take the cube and you break it into its constituent parts, you get a thing called a net. Have you ever seen a net? It's basically, if you fold it all up, it makes a cube, right? So a 3D cube has a 2-dimensional net, agreed? That's 2-dimensional, that's flat, and that's 3. What a fourth dimension, a hypercube does is, can you imagine each one of these little squares? Can you imagine them being cubes? And then you fold the cube into itself. And now you've made a fourth dimensional cube. So what would be surfaces to us are actually cubes fitting inside each other in a fourth dimension. And the animation go looking for it's kind of, for me, it's kind of cool. It's good to go places you don't get examined on, isn't it? Just to see other things, right? So let's focus back on the world. There's a sphere. What kind of things might you be asked to do? We might be asked to find this. What is the intersection of this sphere with the, I don't know, let's say the XY plane. So can you imagine a sphere, right? Which is this thing. And the XY plane is the floor. The intersection is how they two interact. Would you agree you'd get a circle, right? If you took the surface of a sphere and you kind of cut it, it's floating up here, right? And you cut it where the XY plane is, wouldn't you either miss it totally, or wouldn't you probably get a circle, right? Now, the equation of that circle, which is what they're asking here, is what's the equation of the intersection of this sphere with the XY plane? Is very easy to calculate. Here is the equation of the sphere. And I want to find out what it looks like when it intersects with the XY plane. What would we do here to get that answer without any real heavy duty algebra at all?
Set z equal to 0.
Right, isn't z equals 0 the XY plane? So if I cover that up, can you see the equation? The circle would be x minus 1 squared, by the way, that's a square, plus y plus 2 squared equals 9. Wouldn't that be a circle, center 1, comma, negative 2, radius 3? What about the xz plane then? What would this sphere look like if it cut one of the vertical walls, right? The xz plane, right? The one on this side, the left-hand side. What would you get this time? So do this one. Where's my colors? Didn't we make z equals 0, right? That's how we found out this answer. What would you do to find where the sphere intersects the xz plane?
Would you
You would
set
set-
y equals 0?
Yes. Do you notice it's the one that's missing is the one you make 0? Right? And if you made this 0, for no particular reason, there would be your equation. Are you comfortable you could answer questions about, here is the equation of a sphere, tell me the radius and center of the sphere, right?
When
then
you want
question-
to subtract the 2 squared,
Ooh, that is a good point. And let me do that. You do make y 0. Which, just like you said. And so what do you get? You get x minus 1 squared plus 4 plus z squared equals 9. The reason I did that is that this one here is perfectly correct, because when you make z 0, it just disappears. But in this case, you do get a slight change to the answer. You get that. Right. Yeah, you make z equals 0 or x equals 0 or y equals 0. But I want to do another one of them and see if I can make something weird happen. We're going to do x plus 1 squared plus y minus 2 squared plus z minus 3 squared. And we're going to make it 9. So this would be a sphere, radius 3, and the center would be -1, 2, 3. That's the easy part. Let's go hunting for what this would look like if you did the XY plane first. Now, if you do the XY plane, the way you do that is you make Z 0 and replace it into the original. So it's going to be x plus 1 squared. And I've picked this one for a good reason. This is not a circle. If you take a sphere and you make it interact with the XY plane, couldn't you get the XY plane down here, in which case there's no solution because the circle never gets there? Couldn't you have the XY plane might be, say, here? And if that happened, wouldn't the intersection be a circle? But there is a third possibility. Couldn't the XY plane be here? And couldn't the circle just touch the floor? In other words, the sphere is resting on the floor, right? It's not being cut by it. It's not missing it. It's doing it. That's what that looks like. Wouldn't this be the equivalent of it touches at the point -1, 2? Does that make sense? Now, what would it look like if it was this situation where the sphere never reached the XY plane? Well, you could end up with an equation, and I'm just making this up, so it'd have to be a different one. That's what you would end up with. Can you imagine a situation where when you did the math and you made the thing 0 and all that good stuff, right? That you got this equation. Would you agree that circles don't have negative numbers here? So this would be interpreted as it's not reaching or not touching the XY plane. An example of what I just did there is question 9. And working backwards, here is an example, again, still on the spheres. This is an example of question 8. Hopefully it's a pretty obvious question. If I tell you the center and I tell you the radius, shouldn't you be able to create the equation of the sphere? Right, so I'm telling you the center and I'm telling you the radius, and your job is to create the equation of the sphere, right? Okay, X goes there, Y goes there, Z goes there. Is this X plus 4 or X take away 4?
X plus 4.
Great. Would you agree the next one is take away 1 and then take away 5? Agreed? What number goes here where my finger is?
64.
64. Right. Now that you've created this, couldn't you then answer questions like what happens when it cuts the XY plane, the XZ plane, or the YZ plane? And the answer might be the equation of a circle. It might be a single point, or it might be it never does it, right? It misses it totally. And that's what question 8 was about. Covered that. Well, I will do cylinders in a minute, but I just saw something else I want to do. Here is a point in 3D space. What's this one like? So I'll try and draw it. I won't do a great job. But can you imagine P's down here somewhere, right? I want to know how far, right? All these questions are going to be the same thing. I want you to find the distance, right? How far is from P to the following things. Let's do a simple one. What's the distance from P to the XY plane? And you don't need to do any calculations. The answer is in front of you.
Three.
Correct. Isn't the distance from the XY plane the Z coordinate, but you make it positive because it's a distance? Okay. How far away from it is it from the XZ plane then? So the XZ plane is one of the vertical walls. How far away is it from that one?
2.
And that's because it's the Y coordinate. And technically the absolute value, but it's 2. I won't do the third one, but wouldn't the third one be 1? Right. Now, a little bit trickier. We want to know the distance, and we're talking about the shortest distance in every case, to the x-axis. And that's not as obvious as it looks. There's 1, 2, 3. And I want to find how far that point is from the x-axis. So can you imagine there's a little dotted line, and somewhere on the x-axis, right, is the closest point, and I'm going to call it Q. And we want to find the distance from P to Q, right? What would be the coordinates on the x-axis for the point that's closest to 1, 2, -3? What are the coordinates of this point Q on the x-axis?
0, 2, -3.
What do you think? Does that look good? Any arguments about that? Tell me why you did it in case it's a guess then.
Since it's only since you're only having to go to the x-axis, you only have to zero out the x-plane, so that way you're on the x-axis while remaining with your other 2 points.
Right. So basically, if you wanted to know the y-axis, wouldn't you make the middle one 0? If you wanted to know the z-axis, isn't there a kind of symmetry to that, if nothing else? So what I'm going to do is I'm going to call this guy x1, y1, and z1. I'm going to call this the guy x2, y2, and Z2. And if we do our formula, then isn't it this guy squared, that guy squared according to you, and that guy squared. But wait a minute. Isn't the answer just 1? Does that look right?
Yes.
Isn't that the distance to the, not the x-axis, but isn't that in fact the distance to the, we're talking about the YZ plane?
Would you instead zero out the y value because that's the one that's kind of disappearing as we're scooching towards the x-axis?
Oh, let's see what that would look like. Could you do that? Oh, this one's a good one. I'm not going to tell you. Find out. Oh, that's unfair because you don't have time to talk to me tomorrow. Okay. It's this one. Now, it does have symmetry to it, but the symmetry is that you keep the x's the same and the other two are 0. If you plotted this point, wouldn't it be 1 in the x, 0 and 0? Right. Can I draw that again? There is the x-axis. Here is the y-axis. Here is the z-axis. If I plotted the point 1, 0, 0, wouldn't that be the point that is on the x-axis? Isn't 0, 2, -3 not on the x-axis? Isn't 0, 2, -3 somewhere over here somewhere? Actually, probably somewhere down there. So when you want to find the distance to the x-axis of the point 1, 2, -3 to Q, that's the guy you use. If you want to find the distance to the y-axis, then don't you basically do that fella? And you want to do the z-axis. Does that make sense now? That if you want to find the distance to the x, y, and z axis, there is a symmetry to it, but the symmetry is not so much what you're about, isn't it? What you keep. When it was the XY plane, didn't you basically, you rubbed out things, but in this, well, I guess you could think of rubbing out, keeping as 2 sides of the same coin.
Professor, why for y-axis would the
Oh.
-3 stay?
It shouldn't.
Oh, okay.
You got it. You only get 1 of each. Excuse me. Right, let's finish off with cylinders now. Cylinders have equations that look like that, but you could have equations that look like that. And what's the one I haven't done? You could have equations that look like that. Now, we've already kind of talked about these, but just for completeness sake, if you were doing number 1, wouldn't the axis, the z-axis, be the direction that your cylinder is in? So wouldn't you basically get a vertical cylinder for number 1? Great. If you were doing this one, I'll call this cylinder 2. The guy that's missing is y, agreed? And so I know that it's going to be a cylinder, but can you see it orientated in the y-axis? Does that make sense? It's going through the y-axis. And then the last one that we've got, this one here, is a cylinder, and the cylinder is going this way now, right? You know these cylinders are infinite, right? I just have to have a start and finish so you can draw the thing, right? But they are infinite. Great. Now, let's do some of the things that we did with cylinders. Let's have this particular cylinder, right? And what would that one look like? It would look like this guy here, right? If this cylinder cut the XY plane, wouldn't it look like a circle? And its equation would be x squared plus y squared equals 9. Does that make sense? That if this cylinder intersects with the XY plane, isn't the shape that you got left basically that circle there, right? And the equation of that circle is x squared plus y squared equals 9. We're comfortable with that orientation. Now, here's the weird one. So I'm going to have an x-axis and we're going to have a z-axis, right? So I'm down to 2D world. What would this cylinder look like if you found out how it intersects with the XZ plane, which is basically the left-hand wall? What would that cylinder look like if it intersect with the XZ plane?
Would it just be like an infinite rectangle?
Well, if you use inside points, yes. And wouldn't these two guys be at -3 and +3? Great. In fact, if you did only for completeness sake, if you did the YZ plane, wouldn't this cylinder basically just be two vertical lines? They would look like that. And they'd also be at -3 and +3. So if you imagine you got a saw and you sawed this in whatever one of these three directions I told. If you sawed it horizontally, which is XY plane, wouldn't you get a circle? But if you cut it vertically, wouldn't you just get two things and a guy in between, right? But since we're only talking about the surfaces, we really only mean two vertical lines. Let's put inequalities into it then. If x squared plus y squared equals 9 only means the surface, right? Only points on the surface of that cylinder. What does x squared plus y squared less than or equal to 9 mean? What would all the points that have this property look like in 3D space? When it's equal to 9, you just get the points on the curved surface, right? But what would this look like?
Would it be a solid cylinder?
Yeah, a solid cylinder. It'd be like a metal bar. Hey, I've just modeled a metal bar. What would this one look like? This one should hurt your head. What do all the points that have the property that x squared plus y squared greater than or equal to 9 look like?
Would that be a hollow tube from -3 to 3 on the XY?
I like the way you phrased it. That's not the answer I was hoping for, because what you said is correct. The one I hoped you were going to answer is the one that's about to hurt your brain. Isn't that every single point in the universe that's not in that cylinder? Which is essentially what Cal just said. But we're talking about what it is and not what it isn't. So what it is all the points in the universe except for that cylinder. What would this look like? This is not a cylinder.
Would that just be a solid sphere?
No. It is a sphere, but it's not a solid sphere.
Would it be a sphere where you cut out a hole from the center with a radius of
Right.
1? Like it's
Can't,
3 and
yeah,
then you cut out the middle?
haven't I basically built a hollow sphere? A ball bearing with a hole in the middle, a spherical hole. Isn't that kind of cool? One of my Calc 4 engineer students told me that they actually have these now. They're actually created. They couldn't be created until they got, do you know those, damn it, I can't remember now. Do you know those something printers, the 3D printers? Why do you even need or want a hollow ball bearing, right? A ball bearing that isn't all metal. And he told me, and I believe him, that it's done in the aircraft industry because weight is very important. But ball bearings with holes in them, as long as that hole is not really, really big, are just as strong as a solid one, but they are lighter. So NASA and people who don't care that it costs $100,000 for a ball bearing, they're the kind of people that might use hollow ball bearings, right? So you can imagine then that you can model something. Now, if you have an equation for it, can't you plug it into a 3D printer? And the 3D printer will then be able to make it. Basically, you just need to give an equation. And all the 3D printer does is it takes this shape and it cuts it into strips. Right? And on each strip, it puts a bit of, well, the ones you can afford are plastic, but you know the really clever ones now are metal, right? It actually puts metal down each layer. And can you imagine that when you get to the middle, you're going to be building a little circle, and then the next one, a little bit bigger circle, and then eventually you build the whole thing. So you can create almost anything now, as long as you can give it an equation. Isn't 3D cool? And now that I've thought of that, I could create a sphere with a cubic hole in the middle. Wouldn't that be cool? And since I'm the first one that said it, that is a Robertson sphere, right? So if somebody in the future goes and builds one of them, you're going to say, oh, well, I know that one. My Professor Robertson invented that one years ago. I have no idea in the world why anybody in the universe would want to put a cubic hole inside a sphere, but I'm the one that figured it out first, right? So I get the points for it. And that is us for today. I think we've covered most of it. Yeah, I think we've covered most of it. So put your last name down for attendance, and bye-bye, and I will see you later. I'll hang about for those who need it. We learned some cool stuff today. Eli, did we not learn cool stuff?
That was pretty cool.
What about the Robertson sphere? Pretty cool.
Why don't you put a pyramid in there?
Oh no, that's the Eli sphere, or the Holt sphere. Come on, you better grab a shape before they all get used up, guys. Me and Eli have got ours. Kyra, you got an idea of what to stick inside your sphere?
Well, I was just reading the comments, and I think Matthew has dibs on putting a hypercube in a hypersphere. So.
Oh,
if
if you ever make one of them, I want to see it. Right? That would be an impressive thing to make. I'll tell you that right now. In fact, my head is hurting trying to imagine what it would look like. Hypercubes are bad enough, right? When you take a net of cubes and fold them in each other. What would a hypersphere look like? No, can't even think of it. Weird. Bye-bye, Mia. Don't hurt your head thinking of hypercubes.
I just had a quick random question out of curiosity. Yes. Is there a particular symbol or notation you use for intersection of these shapes?
All you do is write down what the equation would be. So if it was a circle, you would say x squared plus y squared equals 9, for instance.
But I just mean like if you're actually like writing down the problem and you didn't want to write out, you know, this sphere intersects this plane, would there be like a
like
equation
a
of the
funny
sphere
little
and
symbol?
like a symbol? Yeah.
Not that I know of.
Okay.
And I'm not saying there isn't one, but I don't know of it.
Okay, just curious. Thank you. Have a good weekend.
You too. Have fun. Right, who's got the question for me? Because I've got some people waiting. So, who's waiting? Who's wanting to go first?
I had a question about the test this weekend. Will it cover 12.1 as well?
Since we've now finished 12.1, it will include 12.1.
All right. Thank you.
Now I think I put let me check on did I put that homework down?
You did.
Okay, then that's good. Yeah.
All right,
Any other
thank you.
questions? No. Maggie, have you got your own version of the sphere yet? All the good ones seem to be getting used up right now.
Yeah, so yeah, well, if I were gonna do it, could I like build something and then stick it in the hole and then build the sphere around it?
Yeah.
Or what if I put a hole in a shape and the hole in the shape?
Ah, so a sphere,
Yes,
right? With a spherical hole, maybe,
yes,
but inside that spherical hole, build a little cube or something.
yeah,
So the cube would have to float inside the hole, right? Or else it would drown.
right. But maybe a
And-
rattle would be cool.
Well, it would be a really cool toy for a kid, wouldn't it? Because don't kids get, isn't one of the toys a kid gets as a ball with little things inside it? And so when the ball rolls, it rumbles and makes
Yeah.
weird noises. So whatever that was, they've managed to do that already. So yeah, you could do that. If you ever buy a 3D printer, you should be able to create one of those shapes we talked about.
Yeah, maybe in the far future.
Well, maybe it's probably not your highest priority of what you want to buy, right?
Right. Yeah, Briggs told us how expensive they were, so
Oh, she must have one or looked into buying one.
yeah, when one of the OC faculty left, she's told us this story when I was in her class. She wanted him to gift her his 3D printer because that was one of the classes he taught. And then he found out that it wasn't actually his. He was just using the school's. So
if you do engineering, you might get to use a 3D printer because I think some of the students get projects where they build things. I know it's ages and you've probably not watched, you've never really been on campus, but if you go into the mesh building, we used to have this glass thing display, and inside it they had some of the things that people made with 3D printers.
oh, that's pretty cool.
So you could try a sphere with your little hole inside it, right? And your little thing inside the little hole if you're getting really complicated. Any questions apart from that? That was
Yeah, I did have a question. It's about the hypercube.
okay. Did you find the video of it yet?
No, but I was wondering if you could just explain this part of it to me. So you said that each of the little squares that make up the cube is a cube, but what is the T factor? Like, what is the time doing? I guess is what
I in this case they're using a physical thing, so time isn't being used. They've just created a fourth dimension, which is another dimension in physical space. So they're not using D.
Okay, that
Right.
makes sense then.
Yeah, but I'm going to hold on a second. If you've got time, I think I might be able to find it.
Okay.
It's pretty easy to go hunting for it. So let me see if I can. You never find things when I want them. Here we go, hypercube. Video. Let's do hypercube. Got one. Right. I'm going to move it over to here. Hopefully it'll transfer. And let's see if I can show you. You got to realize that what they're showing you here is a two-dimensional video, because it's flat screen, of a three-dimensional representation of a fourth-dimensional thing, right? So it's a little bit weird.
Okay.
Right, here goes. Can you see the video?
Yes.
That is what a hypercube looks like.
Okay.
Now, it's basically kind of rotating in this fourth dimension. So what you're seeing is like a little glimpse of what it would look like at any given angle in 3D. And it looks like it's got a kind of cube in the center that's pushing through itself.
Right.
Now, is that not a weird one?
That is very weird.
Now that I've thought of that, I'm going to see if anybody has made a hypersphere.
Mm,
It helps when you put a Y in. Hypersphere? Okay. And do video. Put a P in here. Oh.
oh, that looks complex.
Oh, let's look at this guy.
Wow. That's pretty cool, actually.
Weird.
It's very weird. But it's also pretty cool.
It is. It's almost hypnotizing, isn't it?
Yeah, definitely.
Okay. If there's no more questions, that's us for today.
Alrighty, thank you.
You have a great weekend. I will see you on Monday.
You too.